Hi everyone. Today we present you with our weekly technical insights on Civil 3D. If you haven't watched the previous weekly technical insight video on Civil 3D, I suggest you watch it first before continuing. Capricorn Technology Win Zero company and partner of choice for AC industry is one of the biggest platinum partner for Autodesk and Bentley, along with authorized training centers. We have 300 plus dedicated team members with clientele over 20,000 in AC and associate industries. Let me introduce myself. My name is Shubham Bani, Solution Specialist Civil 3D at Capricorn Technologies, New Delhi. We'll present you with our weekly technical insights. So objective of this insight to showcase a method which can be enhance our productivity and swift completion of tasks, removing repetitive activities by using Civil 3D. Then we're also boosting efficiency and adaptation as well. So tips providing involving automation to line tasks, discovering a new application for standard functions, exploring a lesser known feature, and even using some unlisted commands. Rather than simply presenting a feature by feature breakdowns, we will be providing example of real world problem solving scenarios that demonstrate why these techniques will are valuable. This approach will enable you have a fully understand the reason behind each of these and additional learning how to implement it. In this technical insight, we shall be focusing on add horizontal geometry points into the profile alignment that can be help us to achieve a better profile for our for highway corridor. Then moving to the creation of points into the horizontal alignment for knowing the elevations, northing, easting, and elevation for that intervals. And then how to extract a features line from corridor. It can be helps to achieve our drainage part. So let's share my stability screen. So I have a profile geometry here. So we'll need to click on profile geometry, and here is edit labels. Going to edit labels, we have option a type. In the types, we have horizontal geometry points. We need to select that, and here we'll add in here. And one more window is appear for the geometry points. We will need to show in our profile alignment. So I will show you the alignment beginning and tangent intersection, and that all points for we need to define our and optimize our profile alignment. So we need to click on it. So here is the point which shown here that in that table is added. Click on apply and okay. So here it is in the horizontal alignment. We need to show you the beginning point is 0, 0 plus, and then first our PS, and then SC will be appear here, and the midpoint of the alignment here, the midpoint for that horizontal alignment. The lots of points here, the PC, PT, TSSC will be appear here in that respective profile alignment here. So moving to the next, we will be generating the in the horizontal alignment the same points data. So we need to create a point data along alignment. Here the option for point in point creation tool. Then moving forward to point creation tools, here is the option for that, the major alignment. Before click on that, here it is the point, point creation, the elevation is click automatic, and here it is the option for point description in the automatic, and point name is now. So then moving forward to measure alignment, click on that alignment. Here the option for that layout is for elevation. We need to define the profile alignment. Click on OK. It is will asking the change 0, 0. I'm starting from the change 0, 0, and last change will be 2, 6 B5 2 kilometer from 6. Will enter, and offset will be need 0. Click on enter, and interval will be define a 10 meter interval. Click on OK. Here it is some point will be appear here. Uh, so the interval of 10 meters, the point will be appear, and I need to some elevation. I will checking elevation by using the command of uh, list, then enter and select elevation for that point and enter. Here it is the northing value, easting value, and point elevation will appear. So I'll also defining and here and select similar and here the copy will need to define as a copy and this pasted in another file. So we'll need to export all the point from similar method. So moving forward to next, we will be for extracting the feature line. We'll assigning of the corridor in that alignment. So we'll define the corridor where it is the assembly in assembly, basic assembly and target surface one. So I will be apply here and rebuild the corridor for that. So we need to define some drainage portion and the toe length and here the verge area. So we need to define as a feature line as a 3D polyline. So here it is. I'm clicking on up the corridor, and here the option for feature extract a feature line from corridor. And we need to select that option, and here it is. I'm clicking on that line. This is the toe line. So reach for that, and some drainage portion here. So I'll also the verge area also selecting verge area. That is range. Just need to select that. And just simply click on OK. And here's the option for extract. Just click on extract. All line will be extracting. Here is the one line, second line. Just need to select that alignment as a feature line as exact illusion, and then we'll forward it into the extraction purpose. Need to go into feature line. So here it is a feature line, and we'll export that into XML format. So that's it. I hope you guys had insightful session. Do subscribe to our YouTube channel for all updates. We will be delighted to hear from you. Do reach out us for any suggestions, queries, or topic want to be discussed. See you next week. Thanks, Aiko.